Hello, so in this video I want to talk about an idea which you've probably met before elsewhere, particularly in statistics, and it's this idea of regression, So basically regression is just a fancy word of saying line of best fit. Right, so the idea is that basically we get given some data, so this is some data, this is X and this is Y. So basically this is some data of how Y varies as X changes, okay? So we get given some data about two variables that are going on, okay? And basically the idea behind regression is to basically come up with a line of best fit for this data, a line that best describes this data, right? So the way which you would do that is obviously plot it on a graph and then try and draw a line of best fit through it, and that gives a good regression idea of the data. So this is kind of the idea. So this is X down here, and this is Y down here. So we want to just basically plot this data in. So I'm not going to waste your time, but I'm sure you can do that. So here's the data that we've drawn in then. So we've got our data drawn on. Okay, and the idea is then that we just try and basically come up with a line that kind of draws through this quite nice. Oops, sorry. So we come up with a line that best fits this data. So let's see if we can do this. There we go. So I don't know, something like that. And remember, go back to GCSE, we want the points above the line to be roughly the same as the number of points below the line. So, I don't know, something like that. That will do a pretty good job. Okay, so this is kind of the, this would be the line that best fits this data. So now basically we can say, well, okay, we've got Y in terms of X. Okay, so we've got Y in terms of X, and there'll be some coefficient, and this coefficient here is known as the gradient, so let's call it M. Okay, and we'll be plus some C here, and this C corresponds to the point where we cross the Y-axis. Right, so basically what we can do is we can form, this is what regression analysis is all about. Granted this is a fairly simplified model, this is a fairly simplified way of doing it, but yeah, effectively we get given some data, and we want to basically plot this data or come up with a way of approximating what this data is. So basically the idea is then, if I just write down what the equation of this line is, it's going to be Y is equal to, it looks like the gradient is 3, so it'll be 3x plus, I'm going to call it 3, because it's going roughly through 3, or we know it's going to go through 3 there. So yeah, so basically this is Y equals 3x plus 3, okay, is the best approximation of this data. So this graph here approximates what this data is doing. So this data could be anything. It's describing a relationship between two variables. So therefore Y equals 3x plus 3 is what is the relationship between those two variables, X and Y. Well, okay, so this is the idea behind it. I've hopefully introduced it to you and you've got a pretty good idea in your head. But what regression is in optimization is basically we want to find out some way of optimizing what these values are here. So what this 3 and what this 3 is here. Because obviously we know what Y and X is. Y and X is kind of given in this data. So we know what Y and X is. What we're interested in is trying to find out what these values are in here, or what this value is here and what this value is here. Okay, so this is what we do when we're optimizing. We can use some optimization algorithms or some optimization methods to basically try and optimize what the best values for M and C are, which give the least error. And we'll come on to what we talk about error. It's actually something called a residual. So in other words, this would be an error. Yeah, because fairly obviously this approximation here would give this error in here, because obviously this is the actual data, okay, or this is the fitted data. So this is the actual data, and this is where I say the point should be. So in other words, there's going to be an error of that much, right? And that's what's known as a residual. Okay, so in other words, what we want to do is we want to come up with values for M and C, which give the best possible approximation for data. So in other words, which give the least residuals. Okay, and we'll come on to talk about that in just a moment. So in other words, when we're optimizing something, we want to come up with some function that fits the data. So let's say it's going to be R in terms of some P, where P is just some data. So P is just our data. So like up here, our P was X and Y. Okay, so it's just going to be sort of some data that we get given. So in other words, we're going to have some function that needs to fit the data. Okay, and remember, we're not interested in, we're interested in what the coefficients are. So in other words, what the coefficient x1 is, so that's like your plus c, and what the coefficient x2 is. Okay, and p we're not really interested in. So p is, if you like, taking on the role for our data in X. So whereas before we had Whereas before we had y equals c plus mx. So if you like, our data, which is p, it's like, what we get given, is p. Up here it would be y and x, okay? So in other words, we want to come up with a function. So this is what we want to try and optimize. We want to try and optimize what is the value for m and c. What are these coefficients? That is the point of optimization with kind of regression. We want to basically come up with the best possible values we can for m and c. So I suppose if you like in normal maths, the thing which we're interested in is what the y and x is doing. Yeah, so we're kind of less interested in what the coefficients are doing. Okay. However, in optimization, what we're interested in is what the x1 and x2 are doing, what the coefficients are actually doing. We want to try and come up with a method to try and optimize those coefficients. This is what's known as a regression model. Okay. Now notice, this is important, I need to talk about a very, very important thing now. So this is optimization maths. So I need to talk about something fairly different, which is the difference between a linear regression model and a nonlinear regression model, right? Because say, for example, if I give you something like this. So I get given that, I get given a linear regression model, something like this. So it's r of p, so this is the function that we want to try and find, right? Is given in terms of x1 plus x2 times 1 over p. Will you look at that? Okay, and I'm going to ask you the question now. Is that a linear regression model or a non-linear regression model? Now, a lot of people would look at that and think, well, look, you've got this 1 over p here. You've got this 1 over p here. So if you kind of, treat this as a bit like the case that we considered before, as y equals c plus mx. So this is y equals c plus mx. So this is now no longer x, it's now 1 over x, right? And you'd look at that and hopefully you'd immediately say that's non-linear, right? Because of this 1 over x, it's non-linear. But remember what I'm asking. I'm asking for a linear regression model or a non-linear regression model. So the idea is that regression model, okay, it's a regression model. So remember that the regression model looks at what x1 and x2 are doing. Well, as far as, they don't care about what p is doing. Right, so in other words, if we just kind of treat this as, we just kind of ignore this, then basically you look at that, this is x1, which is linear, plus x2, which is also linear. Linear is basically when you're not multiplying by any other variable, okay? So it's written in, it's a subtract or addition in between, it's got its own separate term, and it's not being raised to any power, or itself isn't a power or something like that. So basically, as far as I'm concerned, this is just x1 plus x2 times something. I don't care what that something is. Okay, so in other words, this is an example of a linear regression model. This is linear because it's linear in terms of x1 and x2, which remember is the thing that we're interested in. Now, fine, this is a non-linear model, but it's a linear regression model. Yeah, the point is it's a regression model which only looks at what the coefficients are doing. You're absolutely right in saying that is a non-linear model. If I said, what is that function there, which is the model, that function there is non-linear, so therefore the model is non-linear. You're absolutely right in saying that. But this regression model is linear because we're only interested in seeing what x1 and x2 are doing. So okay, that's a linear regression model. Here's an example of a non-linear regression model. So same thing, we want to find what this function is. It's going to be equal to x1 times p to the power of x2. So x1 times p to the power of x2. This now would be a non-linear regression model. Non-linear regression model. The reason being is obviously, x1 and x2 are written in the same term. I always look at terms when I'm trying to determine whether something's linear or non-linear. So that, for example, is one term. So a term is just the bits in between the plus or minus, yeah? Well, that now is just one term, and I've got x1 and x2 in the same term. So then immediately I know it's non-linear. But more than that, look what the power is, which p is being raised to. It's being raised to the power of x2. So therefore, it is non-linear regression model. Okay, right. Now that's important, the difference between a linear regression model and a non-linear regression model, because with a linear regression model, you're often able to find what's known as a closed form. So in other words, a closed form solution. So in other words, that just means you're often able to find by some analytic method some formula that describes the model. Okay, so if it's a linear regression model, it basically means that you're often able to find a closed form solution. So you're often just able to find a formula. So for example, y equals mx plus c. That would be the formula, or the thing which we had was 3x plus 3. So we're often able to find a definite formula that describes that data. Yeah. Whereas with a nonlinear regression model, we have to use some kind of numerical search, okay, or iterative formula, in order to find what in order to find what the regression model is. So in order to find what the best fit of that data is, so we have to use some kind of numerical search algorithm. So that's kind of an important difference between a linear regression model and a non-linear regression model. Okay. So then you might be saying, well, okay, so this is kind of where the data comes in to tell us, we use the data and then we want to try and find a regression model that fits it. But then we can also then use an objective function, the objective function. So the objective function is basically telling us what the quality of fit is doing, And that comes into something which is known as residuals, which we're going to discuss in the next module, next video.